Hi, everybody. Brad Truax here today again from Eastman's Woodlands and Wildlife Committee. Uh, it's July. Yesterday we were out kayaking, and I was impressed by the damselflies that were all out. So I thought it's about time we do our video on aquatic insects. Actually, there are a ton of aquatic insects. We're only going to talk about a few of the common ones. Aquatic insects basically are any insect that spends at least part of their life cycle in the water. And they're almost always found in fresh water as opposed to salt water. Very few actually live in salt water. And in general, insects are a very good indicator of unpolluted, well oxygenated water. Many spend several years underwater before they emerge as adults. And many aquatic insects actually have gills during their larval stages. Sometimes those gills are internal, sometimes they're external. And there's even a few that have legs that have been adapted for swimming. Interestingly, if we didn't have any aquatic insects, we'd have no fish or frogs in our streams. And aquatic insects are an important part of the food chain. There are many aquatic insect species, as we mentioned, but we're going to limit our talk today to just a few. Uh, Obviously, all insects have a key role in the food chain. Basically, the sun's energy creates plants. The larvae eat algae, plants, and waste that settles to the bottom of the ponds. The larger insects eat the smaller insects. Fish eat the larger insects. Birds eat the fish, and on and on and on. So they really play a key role in the food chain. Okay, dragonflies and damselflies. On the left is a damselfly. They have a very slender body, and they tend to hold their wings folded in when they're still. On the right is a dragonfly. Dragonfly is quite a bit bulkier, and his wings are spread when he's at rest. So again, dragonfly and damselfly larvae actually spend 1 to 3 years underwater before they emerge, and they spend their time in rivers, lakes, and ponds. They eat other aquatic insects, and they'll even eat tadpoles and even minnows and small fish. And as they grow, the nymphs undergo a series of moltings, shedding their exoskeleton for a slightly larger one each time. Later on, we'll show you some exoskeletons that you might see, say, attached to your dock. They emerge from the water as adults, molt their exoskeleton one last time, and then pump blood up into their wings so that they can fly. We love dragonflies and damselflies. Why? Because they eat many of those other insects that we consider pests. Mosquitoes and midges are their primary diet. And the bigger dragonflies can even eat bees, flies, moths, and butterflies. Male dragonflies are very territorial. Sometimes they'll sit on a perch looking for insects and then return to that same perch once they've captured an insect. Lots of dragonflies and damselflies indicate a very clean, healthy water system, as we mentioned earlier. And they eat many insects, including both adult mosquitoes and mosquito larvae. The dragonflies have very large compound eyes that really provide almost 360-degree vision. And that makes them terrific hunters of other insects. Dragonflies also have independent wing movement, which allows for very precise control and maneuverability. So they're able to hover, glide, perform complex aerial maneuvers. They can even fly backwards. They can fly in almost any direction. And dragonflies are better flyers than damselflies, and they can eat larger insects. So the damselflies don't fly quite as well, but they still consume large numbers of mosquitoes. So again, here's a dragonfly, two views. Again, they're spectacular predators. They capture their targeted prey 95% of the time, an incredible statistic. And that's because they can fly in almost any direction, even backwards. And because they have these big eyes, they can see almost 360 degrees. Uh, Once again, they're incredible hunters, and their success rate when hunting is 95%. That actually makes them nature's most effective predators. As mentioned before, they have four wings that are independently controlled. Each operates in different phases, and that allows them to generate lift both forward and backward. And they can accelerate from 0 to 30 miles per hour in just seconds and reach speeds as high as 60 miles per hour. And once again, those compound eyes that they have process visual information at an equivalent of 200 frames per second. The most we can do as humans is about 25 frames per second. So this allows them to track their prey in really complex environments without getting any motion blur. And engineers have actually incorporated dragonfly features into drone designs. Uh, this picture actually I just came across today on New Hampshire Wildlife. And this is a close-up of a dragonfly that's actually caught his lunch. Yeah, once again, they have these big eyes that allow them to have almost 360-degree vision. They can fly in any direction, they can hover, they can dive, and that makes them successful 95% of the time. And you can see he caught some other kind of insect here. I can't tell what that is, but it's an insect that has wings. Okay, the damselfly is much narrower and daintier. Have a long, narrow body. And notice the wings here are folded in toward the body. So they have two sets of wings that are very similar appearing. And they almost always keep those wings closed when they're at rest. And again, this is showing the difference between a dragonfly and a damselfly. The dragonflies have this thicker body, and they hold their wings out at rest. So here you see two pairs of wings, so four wings altogether, and they're very strong flyers. On the other hand, the damselflies are much more slender. They almost look like a twig, and they hold their wings together when they're at rest, and they're not as strong a flyer as the dragonfly. Once again, this is showing the two. This again is a dragonfly, wings are out. This down here is damselfly, the wings are tight together. Okay, that's damselflies and dragonflies. Water striders are those tiny little bugs that you see flitting about out on the water. They're called water striders, but they're sometimes called water skeeters, water scooters, water bugs, pond skaters, water skippers, water gliders, water skimmers, or puddle flies. So they go by a variety of different names. And they use the surface tension of the water to actually make them able to walk on water. Once again, they're the little bugs that you see flitting around on the surface of the water. And they have very long legs, but their bodies are only 2 to 12 millimeters long. So think about that. Their body is probably only about as long as your fingernail. And their bodies are covered by tiny hydrophobic microhairs that repel the water. Hydrophobic obviously means that it repels the water. And they use the very high surface tension of the water, plus their distributed weight and these long hydrophobic legs to help them stay above the water. And they eat invertebrates, mainly spiders and insects that fall onto the water surface. And birds will prey upon them, but it's interesting that fish seldom eat them unless the fish are really hard up and can't find any other food. Water beetles, basically a water beetle is a generalized name for almost any beetle that's adapted to living in water at any point in its life cycle. And there are probably over 2,000 beetle species that can live in water at some point. And some water beetles carry an air bubble underneath their abdomens, which provides a supply of air. Yet others have developed what's called a physical gill, which permits them to directly exchange gas with the water. And some families of water beetles have hind legs that are adapted for swimming, but most do not. And like many other aquatic insects that we've discussed, some have larvae that spend their time underwater, and the adults are terrestrial. Midges are small two-winged flies. and although some people refer to all small non-mosquito flies as midges. They're often seen in swarms near water or marshy areas where they breathe. And unlike mosquitoes, they don't bite. They have very short lives. The swarms are basically large mating clouds that have huge numbers of mainly adult males that are trying to attract the females. And the midge larvae play an essential part in many freshwater ecosystems. And these larvae aid in both decomposition processes and the recycling of nutrients. And some of the organisms that feed on them include insects, fish, birds, and other aquatic invertebrates. So they're an important part of the food chain. This is showing a midge. Once again, they're small, they have two wings. They're often mistaken for mosquitoes, and they're often seen in swarms near water or marshy areas where they're breeding. And this is our favorite midge story. This is a story I tell. I do a lot of medical and patient safety videos. And there's a process that when we investigate an accident or an incident, there's a process that we call a root cause analysis. The Japanese call it the 5 whys. Basically, you keep asking the same question. Why did that happen? You get an answer, then you say, why did that happen? And so on. So here's the story. This is the Jefferson Memorial. So many of you know that the Jefferson Memorial sits in Washington, D.C., sits near a big body of water. And the Congress was actually debating spending millions of dollars to refurbish the Jefferson Memorial. So a group of engineers and other people got together and started doing a root cause analysis. So the first question they asked is, well, why do we have to spend all this money? Well, they said, well, we have to paint the Jefferson Memorial because the paint is peeling. So the next question is, why is the paint peeling? Well, the paint's peeling because we have to wash it almost every day. Okay, why do you have to wash it almost every day? Well, the pigeons and other birds keep pooping on it. Okay, so the next question is, well, why do the pigeons and the birds do that? Well, they're there to eat the spiders. Okay, and the next question, why are the spiders all there? Well, the spiders are there to eat the midges. Okay, well, midges, again, as we said, are very small insects. They probably only have a life above water of about 90 minutes or so. They emerge from the water. They get in these huge swarms that basically are mating swarms, and they're only there for about 90 minutes altogether. Well, what was going on was that these midges would emerge in the evening from the tidal basin, which sits right out in front of the Jefferson Memorial, and they would be attracted to the light of the Jefferson Memorial. So to make a long story short, the root cause here was the fact that these lights were being put on would attract the midges. And the solution here was not spending millions of dollars. The solution was to turn the lights on half an hour later every night. Incredible story. Okay, another aquatic insect is the caddisfly. And this is really a fascinating insect. Caddisfly larvae live in the water. And here you see the larva of a caddisfly. Okay, this is the larva out here. It's actually encased itself in this really incredible construct that he made out of vegetation that was at the bottom of the water. And that case was built by the larva itself to protect it. And this is what an adult caddisfly looks like. They're terrestrial as opposed to the larva, which spends all its time in the water. So again, the caddisflies larvae live in fresh water, either running water or still water, and the adults are terrestrial. And when they're in ponds, the larvae cut and assemble small bits of vegetation into these homes or cases. And those are really thin tubes. They're often glued together the long way, almost looks like Lincoln log-like chimneys. and they're made of mini twigs, and they're really custom trimmed by the larvae. Really incredible things that they've built. And when they're in a stream or a river, they use heavier building materials like tiny pieces of gravel, or they spin a net that they glue onto a rock or into a crevice. So ways of protecting themselves. And the larvae have a silk gland that produces a silk thread that they use to glue together that case that we talked about. And caddisflies can leave their case, and a naked larva looks like a wet caterpillar. So again, here we see the caddisfly larvae that's living in water. There's the case that he built. And then down at the bottom, after he's emerged from that case, he really looks like a wet caterpillar. And this is an adult caddisfly. They look like a long-antennaed moth. They tent their wings above their abdomen, so it makes them look triangular if you're looking from behind. And this is the lifestyle of a caddisfly. They only live for about a year. Most of that time is spent underwater as in the larval stage. And the adults typically only live for a couple weeks, really just long enough to reproduce. So once again, like many of the other aquatic insects, they spend much of their life cycle underwater, and the time they spend above the water is actually fairly short. Mayflies, don't blink because you might not see them. Some of them, the adult mayflies, may die in less than 5 minutes. Some may live up to a day, but it's a very short lifespan as an adult. But you don't want to get caught in a mayfly swarm, which I'll show you in a minute. So again, immature mayflies are nymphs or naiads, and they live underwater for several years, in contrast to the adults, which live for only a few minutes or hours. The nymphs live primarily in streams under rocks or in decaying vegetation or in the sediments. And often all of the individuals in a population will mature at the same time. We call that a hatch. And then for a day or two in the spring or autumn, mayflies are extremely abundant all over the place, dancing around each other in large groups or resting on every available surface. And these swarms are where mating occurs and really takes place only a few meters above the surface of the water. In many species, the emergence is synchronized either with dawn or dusk. So there's something about light intensity that's an important clue for them to emerge. And the hatch actually can be anywhere from spring to autumn, not necessarily in May, as the name might imply. So this is showing the swarms. Okay, the mayflies emerge in swarms. Here you see an incredible swarm of mayflies that's emerged after dusk. This is at nighttime. And at the bottom, you can see this swarm is left basically covering all these cars and the ground. So the hatch again may occur anytime from spring to autumn, not just in May. So mayflies are again a sign of clean, unpolluted, highly oxygenated water. And the sub-imago stage results from the final molt of the nymph, and it's really a wing version that looks very much like an adult, but is actually a poor flyer. And mayflies at the sub-imago age basically are a favorite food of many fish. And actually many fly fishermen will use flies that are modeled on the mayfly. And this is showing stoneflies, which are another fly that fly fishermen often imitate. So again, stoneflies are considered a good indicator of high quality water. And at the bottom, this is actually a plastic mayfly that's being used as a lure by fly fishermen. So stonefly nymphs usually inhabit clean flowing streams, rivers, and springs, especially where the current is brisk. They usually creep under rocks or other submerged objects. And some species prefer lakes or ponds or quieter waters. The adults are generally poor flyers, so they usually stay close to the water, and especially in shady areas, like the undersides of leaves or underneath bridges. Some of the species are nocturnal, and many are attracted to artificial lights. And stonefly larvae are a favorite food of many types of fish. And like the mayfly, once again, these are usually signs of very clean, unpolluted water. Okay, we can't talk about aquatic insects without talking about dock spiders. We have a cabin up in northern Ontario, and our dock always has some scary looking dock spiders, but they're actually not harmful to humans. They are Canada's largest spider. They can be up to 3 inches big in terms of their body. And they don't spin webs to capture prey. Interestingly, they spin webs mainly to protect their young. And they also have water resistant legs, so they can actually walk on top of the water. Uh, we've seen all these scary looking dock spiders hanging around docks. As I mentioned, they are the largest spider in Canada, with some being up to 3 inches. They don't spin their webs to capture prey. Their webs mainly are to protect their young. And their legs are coated with a very waxy substance that's hydrophobic, basically repels the water. So that combined with the surface tension of the water allows them to actually walk on the water. And they're obviously excellent hunters. They'll eat insects, tadpoles, even frogs, small frogs, and they'll eat minnows and small fish, making them one of the few invertebrates that'll actually eat vertebrates. Remember, the fish actually are vertebrates. And they have sensitive legs that detect vibrations in the water, and that helps them locate and ambush their prey. And they can stay underwater for up to half an hour, either hiding from predators or catching their own prey. And they actually use venom to capture prey, but they're not aggressive toward humans. So even though they're scary looking, we've never seen one of these spiders bite anybody. I mentioned exoskeletons before. The other thing we often see on our docks are these exoskeletons. Basically, many aquatic insects bolt their exoskeleton several times before they emerge as adults. And this happens to be a dragonfly exoskeleton. Okay, now for the bad news. You all know that insect populations in general have been in a fairly steep decline. All you have to do is compare your windshield today to what it might have been 20 years ago. 20 years ago, if you were driving more than 50 miles an hour in the summer, your windshield would be splattered with insects. Okay, now they're relatively rare. So that's your own insect count. And again, worldwide, insect populations have been in a fairly steep decline. And aquatic insects are no different. Aquatic insect populations are declining globally, and some species are facing a significant threat of extinction. Mayflies, dragonflies, stoneflies, and caddisflies all have seen significant declines in recent years. One study actually found 33% of aquatic species are threatened with extinction, and for the caddisflies, it's about 68%. And the decline is driven by a combination of factors, things like habitat loss, pollution, perhaps some biological features, and especially climate change. And given the status of aquatic insects in the food chain, this decline likely has much broader ecological implications. There has been a decline in freshwater fish that's been attributed to factors like overfishing, loss of habitat, loss of river flow, pollution, etc. But we can't help but think that the declining insect population is a big contributor to this decline in freshwater fish as well. So that's a bit about aquatic insects. I hope you come back and see some of our other presentations.